Okay, today, first, before I start, any questions? Always take questions first thing. I'm going to do the problems in section 4, 3-4, and we're going to get into section 3-5. All right. Did you look at the homework? All right. Any questions at all? 4.4. Before we do that, can we do 3-4.1 just to set the stage? All right. If you all see how these things build, they get a little tricky, but they build, right? So for this one, go ahead.
You have two random variables with
Go ahead.
two random variables with a zero mean, and then variances.
All right, so I'm going to just assume it's x equal y bar equals 0 mean. Go ahead.
And then the variance of x is 16.
Problem, right?
Yeah, problem. Problem 3-TAC 4.1.
Problem.
And then the variance of y is 36. And they both have a correlation coefficient of 0.5.
All right, rho x, y equals 0.5. Go ahead.
And then part A is find variance of their sum.
All right, now, last time I showed how it's proven, but y'all remember the sum, the variance of a sum of two variables, in this case x plus y, is just equal sigma x squared plus sigma y squared plus 2, and then it's going to be times rho, the correlation coefficient, times sigma x, sigma y. Do y'all remember that? Everybody? I'm just literally I proved it last time. I wrote out exactly what that was. We took the expected value of x minus x bar over sigma x times y minus y bar over sigma y, and we expanded that and we broke it down. We got this. Do y'all remember? All right, so for this one, now this part's straightforward, but I wanted to do it to set the stage for everybody. So sigma x here is 16, sigma y is 36, right? Plus, then it's going to be 2 times correlation coefficient would be 1/2 times sigma x would be 4. Remember, this is sigma x, sigma y, and sigma y is going to be 6. So that's going to be, what is that? That's 52 and 24. What does it come out to? 76, is that the right answer? All right, next part, I want to go through. I'm trying to make sure, because there's probably some people here that didn't really do them, and I'm trying to make sure, at least when I start talking, you'll have a basis for me to do it. This is the equation that we developed that we're going to be using in this section a lot. Go ahead.
And then part B is to find the variance of their difference.
All right, now this is going to be sigma squared of x minus y. In this case, this guy becomes negative, right? So it's going to be still sigma x squared plus sigma y squared, but now it's going to be minus 2 rho sigma x sigma y. That's going to be 36 plus 16 minus, I think it's 24, isn't it, class? Right? The last part? It's really 4 times, isn't that right? Or 28? Sorry.
Well, the answer is 28.
No, this is 4 times 6 is 2 times, it's 24, right? There, and this is 28's the answer. I'm sorry, you're right. Okay, that's part B. And again, the only thing you're doing, the sign here creates a minus sign there. Does everybody remember me doing this? It's the last part of that section. He's got this formula just before the exercises.
And then part C is just to repeat A and B if the correlation coefficient was negative 0.5.
What did you notice about that one?
They're just reversed.
Only thing that happens, you reverse them, right? Because now, if it's negative, the one that was negative, I mean, what was the plus becomes the negative and vice versa. Okay, so that was that problem. We're doing pretty good here. I'm going to do the next one sequentially. Just for everybody's sake, I'm going to make some comments about what is something that could happen on a quiz. Now we'll take it from there. This quiz, I'm not going to mess up. Go ahead.
3-TAC 4.2. You have two statistically independent random variables, x and y, have variances of sigma x squared equals 9 and sigma y squared equals 25. Two new random variables are defined by...
This is a great one. I like this one. Go ahead.
U equals 3x plus 4y, and v equals 5x minus 2y. And then part A is it wants you to find the variances of U and B.
Okay. So they want sigma u squared, and they want sigma v squared. Okay. Now, you remember, I think we did this in the last exercise. Do you remember when we had coefficients where it wasn't just x plus y being a variable? It was a coefficient like ax plus by. Do you all remember this? So how did we do that? Then this one, for this one, I'll do it right here. Sigma of u squared would be, now you would take 5 and square it times sigma x, right? So it's the coefficient there squared. 5 I'll put 5 squared sigma x squared plus this coefficient, which is 2 squared, right, times sigma y squared. And then what happens here? Oh, I'm sorry. I'm doing this backwards. I should do u first. It's going to be 3 squared is 9 sigma x squared plus, and this is going to be 16 sigma y squared. That's a plus sign, so it's going to be plus. Now before, and I'm going to amend this. I'm going to put it here. He doesn't do this in a book. But if you have a variable like u is equal to ax plus by, and you want sigma u squared, you would take a squared sigma x squared plus, then it would be b squared sigma y squared plus, and it would be 2 rho, and then it would be simply a times b here times sigma x sigma y. Do you all follow me on this, class? With me? We can prove it. Do you follow me on this? Now before, if you looked at this, this was just sigma x squared, sigma y squared, 2 rows, sigma x, sigma y. But because the coefficients are there, if we actually drew this out, we get an AB there. Do you all follow me? And these are the coefficients of x and y. How many remember that? All right, what happens if it's minus? You all agree? Are you with me? Okay. All right. So for this one, what happens? Now this is a plus. So it's going to be plus, and it's going to be 2. What was row again for this?
They didn't give you a row.
They're statistically independent.
What did you say?
It says they're statistically independent.
For x and y are statistically independent? Well,
They are.
are they?
Yes.
All right. Then this should be it. All right. Because if they're statistically independent, what is that going to be? That's 9 times sigma x squared is 9 plus 16 times sigma y squared is 25. That looks like 481, or is it 481 on this one?
Yeah.
All right, I think I did this one. I'm sure, I mean, not in class. I was working a whole bunch of problems, section 3-4 and 3-5 last night, but we did this. So what about sigma v squared? Now again, I'm doing this only because they're uncorrelated, x and y are not correlated, you don't have to worry about that coefficient, but in general, you're going to have to worry about this. You all with me? Here, x and y are uncorrelated. All right, let's go with the next one. How do we get this? Sigma v, x and y are uncorrelated, right? So what does this become? Here's v. Just look, what happens? Got to take 5, it's really going to be 5 sigma x squared, or 25 sigma x squared, right? So it's 25 sigma x squared plus 2, or squared, which is 4 sigma y squared. They're uncorrelated, so there's nothing else to add. And what is that? 25 times 9 plus 4 times 25. 325, is that right?
Yeah, it's 325.
All right, let's keep. Does everybody follow what?
I have a question. Since it was 5x minus 2y, if it wasn't independent, would that be negative 2?
Then this would be negative right here. It would be minus 2.
For the b term, would that be negative also?
Pardon me?
Because b is...
No. This would be the. Now, I'm going to say this. I see why you say that, because I didn't. The a and b here will be magnitude. The correlation coefficient will take care of that. And if you want me to, we can go through the proof on this one, by the way. You can actually do it, but I want to, well, you're going to see this in the next step, I think. All right, now go ahead.
Yeah, the next step is to find the correlation coefficient of u and v.
All right, I'm going to do this over here. So I'm going to leave that there, but so when we talk about the correlation coefficient for u and v, now there's a couple of tricks. This one I think was a trick. How many looked at this one? Do you remember the trick? What we're going to do is create another variable such that either x or y kills itself off. Do you all follow me on this? Now here's why. What if I take a look at this and I want to get rid of that y? If I make a new variable, call it z, is equal to 2u, all right, 2u minus, no, I'm sorry, 2v, pardon me. This is kind of a cool thing. You could do it another way, but this is easier, and here's what I'm going to do. I'm trying to get rid of either x or y there. So when I look at this, I'm going to take 2v here, and I'm going to say I can take u minus 2v and call it, it doesn't matter, w, I think is what he said in the book. Pardon me?
U plus 2.
I'm sorry, plus 2v, you're right. So this is going to be, it'll kill this out, so I have 3x, right, plus, and this is going to be 5x, and then plus 0 when you add them together. So this is going to be a total of, no, 10. This is 10, yeah. This is 10, so it'd be 13x is equal to w, right? Y'all with me on this one, class? Y'all follow me? Now, when I go ahead and I want what sigma w is, or sigma squared of w, this is going to be equal to simply 13, and it's going to be squared times sigma x squared right there. And then if you look at that, there's nothing else involved with that. Do you all follow me? So now I have this. Do you remember the next step? What? I mean, this is it, right? We can put it down there. What is that? 13 squared times sigma x is 20, or is 9, right? Now, what is this equal to? Okay, but I mean, sigma w was equal to squared is really sigma here, and it's going to be of, I got to do this right. Oh, I got to get the correlation coefficient. So the next part of this, I think we got that right. When we want the correlation coefficient for u and v, right? Then I can say that sigma squared of w is equal to 13 squared times 9, and that's the same thing as sigma squared of, and it would be u plus 2v, correct? And that will be equal to 13 squared times 9, and this is going to be sigma u squared, and it's going to be plus, and now, because that's 2v, is going to be 4 sigma v squared plus, and that's going to be 2 times rho vu, and it's going to be times 2 times sigma u sigma v. Do y'all follow me? And again, I had to take that coefficient 2 there because there's a 2v. Do y'all follow me, class? How many looked at this problem before? Just show your hands. Do y'all remember this? How they?
Totally different way.
What's that?
This is a lot easier than the way I did it.
The solution's available. I don't know how they did exactly in the
I
solution.
did it this way, but I didn't know how they got it to.
Do y'all follow me? That 2 comes from this.
And they chose that because they were trying to get rid of one of the x or y variables.
Right, and it makes it easier because over here you just got one variable,
Yeah.
right?
I just didn't know where. Yeah, same as I didn't know where he was getting like the 2 from. But
What he wants to do is eliminate either x or y, because or I should say, yeah, x or y. We've got that information. So I create this variable that I know the standard deviation of. I mean, I should say the variance of that w. And I know that has to be equal to this business because, or I should say, this has to be that because That is, in fact, what W is equated to. Do you all follow me, class? Take a good look at this. All right, so now what is this going to come down to when you do the whole 9 yards? This is, pardon me?
Is that a 40b squared?
The where?
Yeah, I guess 2 squared.
It's 2. I mean, this is 2 squared. Okay? I'm sorry, my writing's. Is everybody with me on this one? This, I was thinking, there's another way to do this. This is much easier. Get rid of the other variable. Now, if you do this, let's see what happens. Then I've got to take this, so I have 13 squared times 9. This is a big number, I think. And then I have to take minus sigma u squared minus 4 times sigma v squared. That's a v. That's equal to all that stuff. So to get the correlation coefficient, I divide by 4 sigma u sigma v, right? And that should be the correlation coefficient from uv. Now, can you tell me what that is? I don't know what it is. Y'all follow me what I'm doing? Can anybody do that? I didn't check. Yeah, I didn't. I checked the answer to the book. I believe it's right here. Just tell me. You with me on this, Trey? If you didn't look at it, this gets a little confusing. But here's the whole deal. And I'm going to put it this way. I don't think this is in the book. Let me put it up here while you guys are calculating that so I'm clear about this. Write this down. I don't think it's in a book. He sort of leaves it to the student to figure it out, or the reader. So if you have sigma of, say, W is equal to AU plus BV, and I have sigma squared of W as a value that I can calculate. Remember, the whole idea is, sorry, I'm doing it wrong. This would be equal to sigma squared of, and however I did it, in this case, you're going to have an equation where W effectively is based on U. So I'm just saying W is equal to AU plus BV. Now, we have sigma squared of U and V. Do you all follow me? So that means over here, he didn't put this down, by the way. He left it to the reader. So that means it's going to be A squared sigma U squared plus B squared sigma V squared. And then it's going to be plus or minus, depending if that's a plus or minus here. And it's going to be 2. And then it's going to be quantity A times B right here. And it's make A and B strict positive, or else the coefficient will mess up. And then you're going to have times sigma x, or sorry, sigma u, sigma v. Now I put that down there because I don't think that's shown in the book anywhere. I didn't see it. He assumes you can figure it out for yourself. And if you look at that exercise, the last exercise in that section, remember he had something like that where he had like 3x plus 4y or something was a variable? You all with me, class, on this one? I hope I answered your question. Yeah.
Is there supposed to be a row in
Yes, there's supposed to be. It's rho of uv. That's what we solve for. That's what we solve for here. Anyway, what does this come down to when we're done at the end of the day?
It's negative 0.16. That's what
I think it's, yeah, that sounds right. Minus 0.16. I did do this. Problem is I don't remember the exact details of that number. All right, now that's a good one because this is the kind of problem you could be thrown. And if you haven't seen it before, you're going to struggle a whole lot writing a huge expansion for this right, or for this right here, because they want the correlation coefficient of 2. So the logical thing to do would be go ahead and add them together and square it and do the whole 9 yards, do the whole thing. That takes a while, by the way. This is easier. And the idea is get rid of one of those variables. Okay.
A great problem.
A lot of great problems you're going to see. This is the beginning of them. All right, next one. Wait, let me just work through it, okay, sequentially. We'll get to number 4 in a second, all right? Because I think there's some people that haven't done this in this class, and I'm sure there are people that aren't here that probably didn't do it, and it's important that at least I go through this. That one you didn't see coming, maybe. By the way, I was trying to do this the long way, You can do it the long, but then I looked up, why am I beating my brains out? That's smart. Well, yeah, you did it with that. All right, next part is
3-4.3.
3.3. Go ahead.
And this is a random variable x has a variance of 9, and a statistically independent random variable y has a variance of 25. Their sum is another random variable z equals x plus y. Without assuming that either random variable has zero mean, find the correlation coefficient for x and y.
Okay. Now, the definition of correlation coefficient, you can go there. I forgot actually how they did this one. It'll probably come to me in a second. But over here, I know, remember, they want the correlation coefficient, right?
The correlation coefficient for x and y. That's just the first part. After that, they're going to want the correlation coefficient for y and z.
Since it's independent.
X and Y are statistically independent, right? And they want the correlation coefficient for this. It's 0.
Is that the answer?
It is 0.
Okay.
It has to be. Look, here's what it comes down to. Sigma of x plus y squared is equal to sigma x squared plus sigma y squared plus, and then it's 2 rho sigma x sigma y. Well, if they're statistically independent, that has to be 0. That's the definition. And so sigma x plus y is just sigma x plus sigma y, but the correlation coefficient has to be 0 for anything where you have y and x. All right? I mean, where the two are added. We could prove that. Do you know how you prove it, by the way? Well, what is the definition of correlation coefficient of x, y? The definition says it's the expected value of x, y, right? Minus x bar, y bar over sigma x, sigma y, correct? Just watch this, you'll see it. Now, these are statistically independent, right? It means this expected value of xy can be written as x bar, y bar, minus x bar, y bar over sigma x, sigma y. It's by definition 0. Do you all see that? That's how you can prove it. Because statistical independence means you can take the integral, basically you just find f of x and integrate it times x plus f of x, or f of y times y, and you do two separate integrals, expected value of x times expected value of y, because they're not dependent on each other, independent. Go ahead.
All right, the next part is to find the correlation coefficient for y and z.
Let's do it over here. Well, I mean, if this is thrown at you, how do you do it? Of y and z, right? We need sigma, I'm going to do it this way, y, z. I don't know how they did it in the book. All right, those are two variables, right? So that's the expected value of y times the expected value of z, right? And then it's minus y bar, z bar over sigma y, sigma z, right? I'm just going to write it this way. Now, I don't know how they did in the book, but I'm going to show you. This is the go-to if you're wondering. Just use the definition of the correlation. So if I take a look at this, what do I end up getting? I have 1 over, and this is, y, z. Sigma y, sigma z. We have that information. Now, the expected value of yz, that's the expected value of y times quantity y plus x minus y bar. And the expected value of z right here is going to be simply x bar plus y bar. Do you all agree with that, by the way? Class? If z is equal to x plus y, and you want the average value, it is the average value of x plus the average value of y. Do you all follow me? All right, now, next thing I'm going to do is say that rho of yz here, I'm going to leave this 1 over sigma x, sigma y out in front. Now, what is the expected value of that? Well, that's the expected value of, in this case, it's y squared, right? And then it's time, or it's going to be plus the expected value of yx minus the expected value of y times x. And it's going to be minus the expected value of y squared. Just take a look at that. I'm expanding it. Basically, I have this y is equal to x plus y, right, times y. You're going to get the expected value. This would be y squared plus xy. So you get the expected value of y squared plus the expected value of yx minus, and then you got to come down here. Well, y is fine, but z is x plus y, so you get these two last terms. Do you all agree with this? Take a moment and just convince yourself if you haven't done it. With me? Can you see in the back? All right, Steve. So now we do this. We say rho of y times z equals 1 over sigma x, sigma y. No. Oh, yeah. Sigma z.
Wouldn't it be sigma, oh yeah, sigma y, sigma z. Because that's what you wrote, the top one up there.
Yeah. Sorry about that, right? All right, follow me on. Y'all with me so far? I'm sorry about that. Okay, what happens now? Now I get, what is the expected value of y squared? Remember this always. Is going to be sigma of x squared plus x bar squared, right? So it doesn't matter what the variable is. X, y, z doesn't matter, right? The expected value of a squared operator, like that, is going to be equal to simply sigma y squared plus y bar squared. Then I have the expected value of xy next, which is just the expected value of x times the expected value of y. So it's going to be plus y bar x bar. Then I have minus y bar x bar and minus y bar squared. You all agree with that? All right, what happens? Now just look at this.
You're left with just sigma y squared.
These two cancels, right? Right? That cancels right there and there, correct? You're left with sigma y over, and it's, sigma y squared over sigma z sigma y. So we have sigma y over sigma z, correct? You all agree with this? Did he do it this way in the book? I forgot. All right, now, once you have that, what's the next step? They want the correlation coefficient, right? What is sigma z equal to? Right here. Sigma z is equal to, didn't I put that up here? Well, z is equal to x plus y. It's just x squared plus y squared. Do you agree with that? Square root of that. Do y'all see that? Because the correlation coefficient is 0. That was the first part. X and y are uncorrelated. Can everybody follow me? It gets a little, you got to stop and think about some of this. All right, so this is really going to be equal to what? Well, we got sigma y, and sigma z is just equal to the square root of sigma x squared plus sigma y squared. Can you tell me what that is? So sigma y is what?
It's square root of 30.
Square root of 1 over square root of 34? Or square root of 34?
The sigma z is square root of 30.
Okay, but what is this whole thing? Sigma y is,
It's 25.
it's 5. Sigma, I mean.
Oh, it's 5, yeah.
5 and 3 is 15 downstairs. Or, I'm sorry. Just do this one. So y is 3, right? Sigma x squared is 25. So we got square root of what? 25 plus 9. That's 34. So it's 3 over square root of 34. Is that right?
3, 5.
What?
Yeah, 5 over square root of 34.
Sigma y, because variance of y is 25.
Oh, sorry, 5. Is that the answer? Y'all follow me? Here's one tip on this stuff, because you can get messed up. If you're looking for a correlation coefficient and you want to do something like this to figure it out, but you don't, suppose they say that you can't assume the means are 0 or something. Follow me? Then you can always go to this, the fundamental definition. That'll get it all the time. But you'll have to expand this out like I did. Over here, I had to expand YZ. That's the key. Use that one and you can't really mess it up. It may take a little longer with the expansion, but you won't make mistakes based on assumptions. Okay? Because a lot of times they'll give you like the second moment or information where you can get the second moment and you'll assume it's 0 mean, but it doesn't have to be. And if it's not 0 mean, then you got a problem. Okay.
Is it wrong to assume that if you're trying to find the correlation coefficient of, like, let's say y and z, it's just going to be sigma y over sigma z? Like, is it
Yeah.
always going to boil down to that?
No.
Okay.
You don't know that. You
Okay.
don't know. I mean, what if these mean values, right here, what we found out that because these are statistically independent, what if y and z aren't, or y and x aren't statistically independent? Then it changes the whole thing.
Okay.
Okay? Work it out is another way of saying it. Don't assume you can get away with something. I wish you could, but I wouldn't assume that ever. All right, next problem. We might as well do them because I think this is, from everything I can gather, doing these problems is useful. Now give me the problem, but before we just brute force it, I want to see your thoughts on this one. This is the one you asked me about, isn't it?
Yes, sir. Okay. But I'm guessing it was like the other one that you just, I guess it's easier for the other.
Is this the one where they got 4 variables or something, 3 variables?
U equals x plus y.
Okay. So now, in general, the way books do problems is this. They add more and more complexity as you get further into the problem set. First problems usually just expose simple theory. By the time you get towards the end, it gets bizarre. There's a lot. So here we got 3 variables, and they say what?
So you have 3 0 mean, unit variance, random
All right,
variables.
I'm going to say z equals y equals x bar equals 0, right? And the sigma x squared equals sigma y squared equals sigma z squared equal 1. That's the only thing they're saying, right? In other words, they're giving us easy numbers. The means are 0, yes. And sigma x, sigma y, and sigma z are 1, or the variance is 1, either one. Okay, now what does he say?
He says that w equals x plus y plus z.
This guy, yeah, the alphabet. Go ahead.
And then random variables x and y are uncorrelated.
All right, now here's what you do. Row of x, y equals 0. Row of xz, is that the next one?
X and z have a correlation coefficient of 1/2.
And row of yz,
Have a correlation coefficient of -1/2.
go ahead.
And then it wants to find the variance of w.
All right, so the thing wants this. So how do you do it? Just think for a moment before I give you the answer. How many looked at this one again? All right, this is a good one. It makes you think. How do you do it?
Would it be sigma squared of x plus y plus z, which we've already found is 1.
Okay, go ahead.
Can't you scale like x plus y and then add z onto that one?
If you want to, you create a new variable. You're absolutely right. But here's what I'm going to show you. Now, it doesn't matter how many variables there are. You can prove this by going to the definition of the correlation coefficient. Or he wants the standard deviation. You can do the definition of the variance of w is equal to, if you think about this, it's going to be w minus w bar, the average value. And it's going to be that squared, right? Times, and then technically times f of x, y, z, dx, dy, dz. That's the idea. It's the expected value of that. You all follow me? Now, if you think about this just for a second, if I want the expected value of squared, which would be sigma omega squared plus, and then it would be simply w bar squared. Do you all follow me? That's just the definition, right? Now, what can you do with this right here? Well, the expected value of w, first you put what it is. It would be the expected value of x plus y plus z squared, right? When you do this, if you look at this for 1 second, you're going to get an x squared, y squared, and z squared component. Do you all see that? All right? You're also going to get cross operators. You're going to get 2 times xy, 2 times yz, and 2 times xz. Y'all follow me? We could go ahead and do this whole 9 yards, and at the end of the day, we would find this by subtracting that, which is just the average value of x, y, and z, which is 0, which is nice, off of this. But you can see that this is this, based on the definition. Do y'all follow me? If this is 0, do y'all agree that that's 0 because x, y, and z have 0 mean? W is x, y, and z. The expected value W is the expected value of x plus y plus z. The is 0. Do y'all with me? So this is this. What is that? I'm going to do this up here. So if I have x plus y plus z and I square it, here, what do I get? I get x squared plus y squared plus z squared. That's the first part, plus, and then I have what? 2yx plus 2yz plus 2xz, right? Correct? Agreed? All right, we need the expected value of all that. I'm going to write it over here. So I need the I'm going to say my sigma w squared is equal to the expected value of all that stuff of x squared plus y squared plus z squared plus 2yz plus 2yx, or 2yx. Let me do it that way. No, 2yz. Let me do it that way. All right. What is the expected value of x squared? Sigma x squared plus the mean of x squared, right? What's the mean of x?
0.
So it's just sigma x squared. I'm taking this one first, so it's sigma x squared plus the expected value of y squared.
Sigma y squared.
That's right, you plus y bar squared, but y bar is 0. That's the beauty of this. Plus, now what is this? Now just think about this. This is 2, the expected value of 2yz, right? Isn't that 2 times the expected value of yz, correct? Right? What is the expected value of yz? And I'll just put it over here. Is going to be equal to sigma x squared plus x bars, sorry. Sigma, this right here is, doing it wrong. Let me do it this way. Rho of xy is equal to the expected value of xy minus x bar y bar over sigma x sigma y. That's what I should have done in the first place, right? That's generally true. So if the means are 0, the expected value is just sigma x sigma y times the correlation coefficient. So that's where I wanted to go. So this is going to be plus 2 times the correlation coefficient yx times sigma x sigma y. And that is 0, isn't it?
Yeah, because they're uncorrelated.
Right? I'll leave it there and cross it out. Plus it's going to be plus 2 times the correlation coefficient of yz times sigma y sigma z plus 2 times the correlation coefficient of xz times sigma x sigma z. So that's what this is. And now I'm going to start do y'all agree with that?
There's supposed to be a sigma z squared in.
Yeah, at the beginning.
Oh, yeah. You're right. So it's plus sigma z squared. I'm sorry, I'm going through this too fast. You with me on this, class? Just account for all those things. When you do it, what do you get? Sigma omega squared is equal to, let's see, that's equal to sigma x. They're all 1, right? So this sigma x squared is 1 plus 1 plus 1. And that takes care of x, sigma y, and sigma z there. Now the correlation coefficient of xy is 0. So the next thing is 2 times this. So it's 2 times 1/2. And it's sigma y, sigma x is 1. And then it's minus 2 times 1/2. And it's times 1. So it's 3. I guess that's the bottom line on this. that sigma omega squared is 3. You all with me? You asked me about this, but you follow the reasoning behind it, why I did what I did. What's the next part?
To find the correlation coefficient between W and X.
All right. Let me do it here. First, I want to put this up here. W is equal to X plus Y plus Z, right? And now they want the correlation coefficient between W and X, right? Correct, class? So I'm going to, by definition, what is this going to be? Well, the correlation coefficient of W and X is equal to the expected value of W times X minus W bar times X bar over sigma W, sigma X. We have sigma X, we have sigma W, so we got these. What do you know about this, by the way? Why is it 0? You're right.
Because this question statement says it's 0.
X bar, they state as 0, correct? 0 times anything, you don't need to calculate W bar, even though it is 0, correct, class? So I can get rid of that. Now, I don't want to do anything too fast, but you'll follow, I don't know how they did in the book. Sometimes they do all these shortcuts, but here, what is the expected value of, well, let me do it this way, of W times X. Just write it out if you're wondering. Don't look for a formula that doesn't exist. This is the expected value of what? What is W? X plus Y plus Z. And then it's times X, right? And that last part goes away. Do y'all follow me what I'm doing? I'm just literally putting in to the expected value the definition of W, X plus Y plus Z. And that is what? By the way, sigma X is 1, sigma W is going to be 1 over square root of 3. All right, this is going to be the expected value of X squared plus the expected value here, and it's going to be of YX plus the expected value of XZ, right? I'm going to write it over here. Do y'all agree with that, class? Take a moment, just make sure you see what I'm doing and know why I'm doing it. Remember, our goal is over here, right? We want this. With me, class? So what's my next step? I can say that, what? The correlation coefficient of Wx is going to be equal to 1 over square root of 3. I'm going to leave it as that. There may be a mistake in his answer in one of these. I forgot if it's here or the next section. All right, so what is the expected value of X squared?
Sigma X squared.
Plus X bar squared, right? X bar is 0 sigma X squared. Good. I'm going to leave it as sigma X squared. We'll put the 1 in a second. Now, what is the expected value of YX? Y and X are uncorrelated, right? Which means it's, they're statistically independent, right? What's the expected value of X times Y if they're statistically independent? X bar, Y bar, isn't it, class? Isn't that right? You follow me on that one?
Yeah.
Look, if you have the expected value, if they're statistically independent, what it means is this. If you have the expected value of X times Y, usually it's a double integral, and it's X times Y of f of X comma Y dx dy from minus infinity to infinity, or wherever they exist, right? If they're statistically independent, you can say the expected value of xy is y. That's equal to the integral of x, fx of x, right, dx, times the integral of y, fy of y, dy. Because this thing you can break up into two functions from minus infinity to infinity, minus infinity to infinity. And that, in fact, is the definition of x bar, and that is the definition of y bar. That's what I'm trying to say. Even though they're uncorrelated, that would be the definition, right? If they were correlated, then you would have to take the expected value of xy minus x bar y bar over sigma x sigma y as the correlation coefficient.
How do we know that they're statistically?
It says it in the problem. Do you have, if you don't, do you have access to the PDF? It says in the very beginning they're statistically independent. If they weren't, they would have to give you a correlation coefficient.
So in the book, I don't see where it says that.
Yeah, it doesn't say that.
Uncorrelated.
It says X and Y are uncorrelated.
Uncorrelated is the same thing as correlation coefficient is 0.
So that just means they're statistically independent.
Yeah, I mean, if they're uncorrelated, they're statistically independent. What it really boils down to is there's no relationship between one and the other. Now, back to this thing. So that is sigma x squared. This is equal to what? X bar, y bar, right? And what is x bar and y bar?
0.
They say 0. Follow me on this? Which you are right, because that. But then finally, what is the expected value of xz? Are they uncorrelated?
They're correlated.
They're correlated.
In 1/2.
All right. So then, what you do is this, and I think I've done it a few times. I'm going to do it right here. I know what the correlation coefficient between
X and Z.
x and z. Sorry, x and z is equal to the expected value. That's what I'm after. Of x times z minus x bar z bar, right, over sigma x sigma z, correct? Now, sigma x and sigma z are 1. Whenever I see people yawning, I know I better get going on this one. So I'm going to get rid of that. What's this?
0.
0 by definition. So that means the expected value of xz is the correlation coefficient, correct? Which is what?
1/2.
So this is 1/2, and that's this, all right? And then, so that means rho of wx is equal to 1 over the square root of 3, and it's times 1 plus, yeah, that's right, plus 0. You were right, plus 1/2. So it's 3/2. I think this is wrong in the book, by the way. 3/2 over the square root of 3. So it's really what? Square root of 3 over 2. What does he have? All right, he was right there. I think there's one coming up that's wrong. What's the last part?
Is to find the correlation coefficient between W and the sum of Y and Z.
All right, so I think you can guess what I'm about to do. Sam, is this the part you were bugged about?
Just this whole thing, I don't really.
Are you following?
Yeah, the expected value of x.
Now, the next one I think has a wrong answer. Who did this problem or looked at? Did you find a wrong answer in there?
I wasn't able to get an answer for C.
I think they're wrong, but we're going to get it. All right, hold on. All right, so now they want the correlation coefficient for what?
For W and the sum of Y and Z.
All right, now it's just getting irritating. That's the only thing they're doing, is making it. What is W? X plus Y plus Z, right? Y'all with me on this? So if we're taking a look at this correlation coefficient, I'm going to create a new variable just because I want to try to make sure you see the reasoning behind it. If you wanted to do this, a good way to do it is this. If we say that this is equal to the expected value of these two things, which is going to be W times Y plus Z, and then it's going to be minus W bar, and then times Y plus Z bar over sigma W, sigma of Y plus Z. Do y'all follow me on this, class? In other words, instead of putting a variable U there or something like that, I leave Y plus Z in there. Do y'all agree with that? All right, now, you know what sigma W is, didn't we just get that?
It was the square root of 3.
Yeah, it was 3 would be sigma W squared, all right, the variance, so square root of 3, we got that. We have this too, right? We have the correlation coefficient between Y and Z, right? What is this going to be? Well, what's the average value of Y? 0. The average value is Z, 0. Add the two together, average value is 0 times anything is?
0.
You see how I can negate that thing? So I'm going to get rid of this part. just to make life easy. Now, I have these two values, right? The only thing I need is this. You agree with me? Let's go ahead and get it. I'm going to do it over here. This one, I was sitting on my chair trying to do this thing. As I recall, it was around mealtime. I had my dog going nuts, my wife bugging me about stuff, and it seemed to go on and on. I'd have to stop, restart. And I used to tell my students, don't ever do homework and stuff like this in any kind of environment with distractions, and I violated that rule. So I'm not going to do it anymore if I can help it. But it takes much, much longer. All right, so this is what I need. So I need the expected value of, and what is W? X plus Y plus Z, right? Times the expected value of Y plus Z. How many see where I'm going with this? Just raise your hand. I'm going to square that thing, or I'm just going to multiply them, right? What do I end up getting? I get the expected value here of, I got X, I'm just going to multiply them through, right? So I got XY, then I have plus the expected value here. Maybe I should do this first. Let me do it this. I'm going to multiply the whole thing. That's the expected value of, this whole thing is going to be XY, right? Then I have XZ. Then I have Y squared. Then I have YZ. Then I have the expected value of YZ. And then I have plus Z squared. Now, just take a look at that. Do y'all agree with that? If I multiply the thing out? Okay, let's talk about this. I know the expected value, if I look at this, of XY is what? I know it's 0, right? Or is it? It's 0 mean, right? It's the expected value of X times the expected value of Y. Expected value, because they're uncorrelated, expected value of X and Y are 0 by definition, and Z. Do y'all follow me? So that goes away. What about this? I'm going to leave it down here. Let's see how many XZs I have. I got 1 XZ, so it's the expected value of XZ. We'll talk about that in a second. So I've got this one and this one. Plus, what is the expected, I'll just leave it, expected value of Y squared, right? Take care of that one, plus the expected value of Z squared. Take care of that one, plus 2 times the expected value of YZ. Are you with me? This is just the expected value of all this business, which goes here. I'll get out of the way in 1 second. But you all follow me. Once I have this, I got this. Correct? It's a longer problem. You just have to stay focused. A lot of times, a good engineer, the guys that are really high paid are very good accountants. They keep track of everything. That's one of the differences that separates people. They get, you might say, clumsy mathematically as things get tedious. Don't do that. All right, now, I'm going to go in and just say, what is any of these things when we take a look at the correlation coefficient between, say, anything? XZ. Well, that's the expected value of X times Z minus X bar Z bar over sigma X sigma Z, right? You'll notice this is 0 by definition. X bar and Z bar are by definition 0. That means it's in sigma X and sigma Z are 1, right? So the expected value of XZ is just the correlation coefficient of XZ, correct? So what I'm going to do, I'll do it right here. So this becomes simply 1/2, I think, right? Isn't that the correlation coefficient of XZ? Can you confirm or deny? Right? What about the next part? So I take care of that, plus, what is the expected value of Y squared?
Sigma Y squared.
Sigma Y squared plus Y bar squared. Y bar is 0, so it's sigma Y squared, which is 1, right? I think, correct? Next, I hope so. Next one, what is the expected value of Z squared? 1. What's the expected value of YZ? It's actually got a 2 there, plus 2. Correlation of YZ is minus 1/2, right? And sigma X, sigma Y, and sigma Z are 1, so there's no other problem there. how many see what I'm doing here? Trying to get to the bottom line. Are you with me? Trace, you follow me? All right, now, what does all this come down to? Let's see. I got 1/2 and 1 is, let's see, I got minus 1 here and 1, so get rid of these two, right? And then I got 3/2 here. I think this is the wrong in the book. Do you all agree with that? And then what happens? Over here, I get the expected value of x, or sorry, I get right here. I'm out of room. Let me just put it down here. So now I have all this business here after I square it out. This comes out to 3/2, right, on top? That's what we just did with me? Now what's this? Well, we got sigma w as square root of 3, didn't we? And what is sigma yz?
Sigma y plus sigma z both squared.
Sigma y plus z is sigma y squared plus sigma z squared plus what?
2 times
2
their
rho yz times sigma y, sigma z, right? All right, what is this going to be? Sorry, I'm trying to. That's 1 plus 1, right? And it's going to be minus 1 because the correlation coefficient is minus. Correct, class? So that whole 9 yards on this is just 1, isn't it? So this should be what? That's the answer for that thing. So let me just simplify it. And they got it wrong in the book, I think. I think he made an error. He had the right statement, but the wrong numbers. He forgot to divide by sigma of w, I think. So that's going to be, well, I have 3 over the square root of 3 is going to be square root of 3 over 2. I think he does something where he's got it wrong. Isn't that right, class? 3 over 3 to the 1/2 is square root of 3, right? Divided by 2. What does he have? I think it's wrong.
He has that answer.
He does? Who has my solutions? Okay, is that what he has? Okay. You all with me on this one, class? I thought it was wrong. I mean, well, maybe I had a difference. Is that solution manual modified or is that? No, that's for a different part. But you all follow the way it went. It's just a tedious problem. There's nothing tricky. Just follow out. You have to do a lot of multiplications here. And then you have to do all that stuff. Now, I think that was the last in the section, isn't it? I want to talk about section 5. This is important. Section 3-5. I wanted to get there earlier, but I'll deal with it now. I wanted to get through these problems because these problems there's some of them that are tricky, especially that one where you have to create a variable. That variable we multiply one of the variables by a constant, so when you add the two together, you effectively nullify either x or y. All right, so here, this is a section 3-5, and here what we're talking about is going to be, I forgot how he termed it in his book. What does he say in his book about? What's the name of the section?
Density function of the sum of 2 random variables.
All right, we're trying to determine the density function. So if you have z is equal to x plus y here, he's going to start this way. We're going to see something neat happening. All right, so then he's going to say, well, the probability of random variable z less than z is the same thing as the probability of x plus y less than z. And this z is some value. This is a random variable. All right, so what is this? Well, if you think about it, technically, you don't have to write this down. Just listen to me. It's right in the book. Anytime you want the probability of anything, and you have a density function, you're going to take the actual density function, which is f of x comma y here, dx dy. And now, well, remember, this value is going to be given. So if you want to do the dx integration first, here x would go to z minus y. Just think about this. X plus y equals z. If z is given here, and you wanted what x goes from, it goes to z minus y. Do you all follow me? These density functions, technically, if you wanted this, go over a range from minus infinity to a point, minus infinity to another point that would deal with the value of x and y. For x, it goes from minus infinity here, and it stops at z minus y. And then we do dy integration. Now we go from minus infinity to infinity. Think of it this way. If you have the equation, say, I'll take it in terms of y on the vertical axis, x on the horizontal. Y here would be z minus x, correct? Now this region, this is a planar region, and the actual density function would be out of the board. It would be a surface kind of plot. If you draw that, that's a straight line, right? So the probability of x and y being less than z, put z in here, it's really the probability that would be found by integrating the function over this region of space. Do you all agree with this? This would be an f of xy integrated over that region. Just keep that in mind. That's that, right there. Now, if you wanted the value of the density function, f of z, well, that would be the derivative with respect to z of all this, of that density function. Let me break it down for you so you can get this. All right, a lot of abstract stuff, but you should at least conceptually appreciate what I'm trying to show you. Now, here's the problem with all this. To do this as it shows, the way it's shown right here, you would have to actually do an integration of f of xy dy and then put, or I mean dx, and then put this limit in for x, the upper limit, and subtract that, then take the derivative. You would get f of, and it would be f of z minus y comma y integrated dy. When you take a derivative, you're just going to get the upper limit here. It's the only thing that matters. He states that if you assume that x and y are statistically independent, and I'll get out of the way and say, sorry, are statistically independent. That means that f of x comma y is equal to f of x times f of y. And that happens a lot, by the way. So many things in the real world are statistically independent in nature. And you'll see this with like the Maxwell-Boltzmann distribution, with Rayleigh distribution, all this stuff. All right, so if that's the case, then you can say, and I'm just going to cut to the chase because I think I got about a minute or two, f of z, and this is in the book, and I'll give you the formula. When you do the derivative of this, you're going to get an integral from minus infinity to infinity here, and then it's going to be fx of y minus z, and this is going to be fy of y dy. Now, where is that in the book? He'll show you this equation.
It's on page 137.
What's the
book.
equation number?
Let's see. F of x of y minus z. It's 3 tac 30.
I want to say something about this. If you look at this just for a second, you notice we have f of x and f of y. What is that really? That's convolution of the two functions. Yeah.
Would that be z minus y instead of y minus z?
You're right. Z. Yeah, z minus y. I'm so sorry. You're absolutely right. It has to be this. My bad. Now, that's simply convolution. I want you to appreciate this. Back in the day when you did convolution, and you're going to have a real appreciation for convolution, especially I think when you get in your senior courses. You haven't had comm yet, have you? When you get into communications labs, convolution is everywhere. You're going to get correlation and convolution. The two are very similar, but I want to just share this with you. When you take two functions convolved, if I have f of x convolved with g of x, and call that y of x, it doesn't matter. Well, convolution implies integration. Technically, it's the integral from minus infinity, technically to infinity, of f, and then it's going to be of whatever the dummy variable is, call it lambda, and then it's times g of, and here it's going to be z minus, x minus lambda d lambda. A lot of times it's tau. It doesn't matter the variable. You're integrating out the dummy variable. That is the definition of convolution. If you look here, it is the definition of convolution of two functions. Are you with me? The argument is z at the end of the day. So this part right there would be the thing that survives. It's like the x over there. Now, let's take a look at the example. If they're statistically independent, remember, it's just convolving two things, okay? And you get that by doing this right here and assuming they're statistically independent. Let's go to the exercise because you'll see this. Let me just finish this thought, please. Exercise, whatever that's, 5.1,
3 Tech 5.1. Let x and y be two statistically independent random variables
good.
having probability density functions. F of x equals 1 from 0 to 1, 0 elsewhere.
And 0. All right, so it's, and then f of y is the same deal. Of y equals 1, 0 greater than y, less than 1, and 0 else, right?
Yes. And then the random variable z equals x plus y.
Yeah. All right, so he's saying that the random variable z is equal to x plus y. If you get x plus y, and you got f of x and f of y, that's it. You simply do a convolution of the two functions here and here. I want to do this for you just one time. I just, let me finish this thing before Friday. All right, how do you convolve two functions? Anytime you're convolving any two functions, I'm going to do it by really visualization and let the image aside. So you find the one with the most going on. In this case, they're identical. And you plot that versus a dummy variable. So I'm going to plot my f of x of, and I'll call it lambda here. And it looks like this. From 0 to 1, here's lambda. Then you take your other dummy variable, or other function, pardon me, and you plot it versus the dummy variable with a minus sign. You all with me? So now you plot f of y of minus lambda, and that's this. Can you all follow me? How many understand that right there? We're doing convolution. So now the definition of convolution, and I'll put it here, because this is a multiply, you multiply the two functions at a given point, right? And then you do the integration. So it depends the value of x here or the value of z. And I'll just say this. I can say that my f, let me do it this way because I'm out of time. I can say the density function for z would be the density function of x times lambda times the density function of y, only now it's going to be z minus lambda d lambda. Do you all follow me on this? So what you need to do is see the area of overlap. Remember this right here, this point technically, the upper point for this, I'm going to go ahead and add the z here. If I have z minus lambda here, the upper point here would be z, and the lower point here would be z minus 1. Do you all follow me on that? This is versus lambda. So if you look at this, as z gets greater and greater, this whole window is moving that way. Now, for z equals 0 or less than 0, there's no overlap of the two windows, so when you multiply them, you get 0, right? So that means f of z for this one, and this is just basic convolution, f of z equals 0 for z less than 0. Now f of z equals, and now we take a look at this. Now let z be greater than 0, but less than 1. This thing's shifting through here, and the area of overlap would be here. Do you all follow me? So when z is greater than 0, but less than 1, now we have to get an equation for the area under here, right? Because this has got, the density functions are just 1. He made them so nice. The peak value here is 1. 1 times 1 is 1. So it's the area under that thing, which is just going to be z times 1, isn't it? Right? All right, so that's just equal to z. This is a great one, right? Now, that's true between 0 and 1, right? I'm trying to hustle here. I know. I appreciate you staying with me. So what happens when the window is greater than 1? Right? This part is still z. This is z minus 1. But you can see that the area of overlap would be here. Do you all see that, class? I'm really moving on this. How many do? Can you all follow me? So how much area is under there? Well, it would be 1 minus z minus 1. Do you all agree with that? So for z greater than 1 but less than 2, this is going to be z minus 1. Finally, when z is greater than 2, now there's no area of overlap. Can you all see that? How many see this right here? So finally, this is f of z. For f of z greater than 2, it's 0. Now what does that look like? Just plot it. It looks like this. And he shows you this. This is what's nice about this. So I'll tell you more about this later, but it does this. All right? This is going to be versus z. This is 2. This is 0. This is 1 is the peak value. You all see it right here? And that's it. And the peak value is 1. This is my f of z. Isn't that in the book? Is that shown? Doesn't he show you there? It's in the exercise, right? We just did.
Yeah, he doesn't have a picture of it.
All right, but you all see that, class? That's all it is. Now, here's the deal. Here's the thing I want to tell you. If you have z equals x plus y and you have f of x and f of y, you convolve them. If f of z is x minus y, then it's really going to be correlation. And the only thing that happens is this becomes plus here. And I'll talk about that next time. I want you to go through and try these problems. So for the quiz, it'll be out of section 4, and maybe a bonus having to do with that. Convolving two functions, all right? But I want you to do the homework, okay? Make sure you do section 4's homework. I'll give you this. And I'm sorry, I owe you some time. Thank you for staying with me. I wanted to get this done. It's irritating to not be able to get this. I have a trajectory where we're going. I don't want to have to do a whole bunch at the end of the semester. The stuff in the last section, some of it gets a little bit harder. This is going to get real heavy. Some of this stuff here, in this section, and this stuff.
In signals and systems, it was convolution was always the hardest thing to understand at first. Like, if you have two functions, like two squares, which one do you know to move? That was like always my biggest issues, like knowing which one to like slide across.
Well, you always, the one with the most going on, you don't move.
Right,
Just
keep
stick
that
it.
one.
The one with the least going on, you shift it